I know.
That was so hard.
Are you ready? All right, so 60% of you already turned in 611 and 612. That was technically ahead of time. If you're doing a drum solo, I'm going to wait for the solo. Done now? Okay. Moving on, so we might have time to get back to Desmos. If you didn't turn in 611, 612, you should. But if you've already, because you're trying to be an overachiever, turned in 614, you need that today. The front of it is in classwork. So if you already turned that in, get it back. But I don't think that's very many of us, because unless you turned it in today, I don't think you did. I will tell you right now, this is no indication of what you are about to make. Last year and every previous year, everyone's like, oh, it's going to be a dinosaur. No, it's not going to be a dinosaur. So, on your 434, on your 6 paper number thing, 614, we are going to follow these directions. And what we're not going to do, what you are not going to do, is when you realize what it looks like, shout out, oh, it looks like a, because that's lame. So we are now working on physical applications of rigid transformations. So everyone should have their 614 worksheet out, not working on their 613 homework. And we should be following these directions from the top down. So the first thing we have to do is draw a rectangle that does not exist on our paper yet. If we can do this while having some tunes on, I will turn on some coffee shop music. On the space on the front of 614. So on the front of 614, on the front of 614, we're following these directions. Yeah, if you'd like the lines to be straight, you can grab a ruler.
I hate lines. Give me that ruler, Aiden.
Oh, the other thing, please give me a moment to talk while you're not talking. The other thing that I wanted to make sure you guys know, if you get to 100% of homework turned in, you win no matter what. But what that means is multiple classes could win on the same day. You could essentially tie for first place. Right now, 1A and 3B are tied for first place. So what would be the best bet for you guys is if you get to 100%, unless the other classes get to 100%, you win. And you take your second victory, and then we're all tied across the board.
And then we have 2.
Correct. So, up here we're keeping track, right? 1A is on a tiny bit of a streak, right? It was 3B, then you guys, then 3B again, then 1A's had a couple victories. That's partly because I've been strongly suggesting that certain people come to math lunch, so they have gotten their feet under them and they're doing homework better now. Not at all. Anyone can always come to math lunch. You know very well that now we're opening up the wall and making tons of space. Max.
It's just really hard to juggle old work with new stuff, especially because the new stuff is due sooner, a lot sooner. So it's really hard.
Yeah, except for not this week. Because remember, like we talked about earlier in the week, I heard you. I heard that feedback. 611 was assigned Monday, not due till Thursday, right? So you technically had 4 days to work on this. 612 you got on Monday. It was technically assigned on Tuesday, and you have till Thursday. So I agree, but kind of what all of us teachers are echoing each other on is, I got no advice except for do your work, right? I agree with you. juggling old work and current work is tough. So you got to catch up at some point, right? Over the weekend, over Thanksgiving break was an opportunity. It's like we don't lift our foot off the gas pedal here in second and third quarter. We're going. We're driving. We're foot on the gas pedal. You thought what? So remember, this is a soft, you maybe weren't listening. Hey, I need to make sure you're listening right now. You maybe weren't listening when we went over this stuff. The yellow is telling us you should be done with it. Turn it in if you are. The red is it's actually due. Ha ha ha, due. It's due, and it's going in math tonight. Well, maybe not tonight. Probably not till the morning because I have game night tonight. I'll probably nerd out with my friends. All right, let's make a not dinosaur.
I want to make a dinosaur. If it's not a dinosaur, I will be zero.
If you'd like the opportunity to make a dinosaur, that's where this worksheet comes in. What? She's probably just leaving. Calm down. Don't eavesdrop on the radio. All right, do this.
Wait, do we have to describe it to you?
Once you have it, I mean, you should be able to tell me what it looks like once you get it there. I need to scroll down here once we get past the first couple steps. Once you have these directions done, you may come up, show it to me, and get the other worksheet where you make a challenge for a friend.
A dinosaur.
You can make a dinosaur if you want. Why is your hand in the air? Please do not say out loud any spoilers. Okay.
What's the middle?
What's the what?
Middle.
What do you mean the middle of B right now? So the first thing that talks about B is here, I think. Oh, the middle of A right now is -7, +15. So for circles, the center is the center. I feel silly saying that, but the center is the center. So we have to like average the locations. So this is -8, this is -6, so the middle of A is -7. How high is it up on the Y? The middle of A is 15. So right now, A is at -7, 15, centered at, but then we get told, translate circle A so its center is at 7, +6. What you really care about when you go to do that is that it stays the same size. So your circle should only be 2 boxes tall, 2 boxes wide. Do we all have the rectangle?
Yes. Mine only has 3 sides.
Okay, like go ahead and finish it. I'll scroll down in a minute.
How it only has 3 sides.
I'll scroll down. Well, you just gotta draw the 4.
But like, it doesn't say what. I mean, I know what the 4th is. Like, it doesn't.
It's giving you the coordinate points, right? Vertexes. Yeah, so you did boom, 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 and then because they told us rectangle, we just go ahead and connect them. Yeah, because rectangle has got 4.
I was like, why did it say that?
Rectangle either means 4 or an angle that got super messed up.
How funny.
Get it? A rectangle. Oh. I can tell you I've never heard that. I was just over there, but then Brenda stuck her hand up. Does it tell you about what? Ooh, clockwise, about the point, -6, +3. Hockey stick method. Hockey stick method. All right, we're all good with the rectangle? All right, I'm scooching it up so you can see more. When you rotate, guys, we talked about this, but we haven't done it on paper yet. When you rotate, you have to know your center of rotation. That tells you what to pivot around. So we're going to go 180 degrees clockwise. Guys, it doesn't actually matter clockwise or counter because 180 degrees is half a rotation. But around the point -6, +3. So my center of rotation, where my hockey stick is going to stay locked, is right here. And we rotate clockwise. Like we said with the hockey stick, it was 3 up, 2 over. Now it's going to be 3 down, 2 over, but in the opposite direction. Oh, it looks like a pinwheel. If I add a few more,
Wait, is this
I could make I could make a windmill.
Yeah.
Some triangles rotate around.
Thinking of like the winding that's on the top of barns. Like, yes, that is a
like a
windmill.
weather vane?
Yeah, that was what I was
Ooh, then add 15 to each x coordinate.
So every x coordinate?
On the circle or on the triangle.
Okay.
Because this step is about the triangle, right?
Wait, I'm doing this completely wrong.
I'm going to add some color so you guys can keep track of things when you look up here. What are those?
Where was the rectangle?
How
do you do that?
How do I do what?
Just straight off on straight.
It's smart.
It is?
Yeah, like it is smart. It knows what I'm trying to do.
It does?
But if I'm too sloppy, it can't do it.
Oh.
Yeah. So if I'm close enough, it fixes it.
Fancy.
Do we all have circle A moved?
Yeah.
Okay, because I need to scroll down so you can see the rest of the instructions.
I don't know how to do it.
You guys can help each other out, too. You can help each other out. Help each other out. Ooh, I still have coffee. Happy day. What?
No.
Do not shout out, oh, it looks like a...
Look. No, rotating is it's rotating. B is just reflecting. Alright, fine. I did.
Ow, I am. I'm not completely misunderstood this and then done trying to completely wrong. Then I 15. Oh. I probably did. What the verticals mean? Like this coordinate?
Vertices is plural of vertex.
And what's a vertex?
It's just interesting that it's overlapping. I would double check the directions that you follow for that. Also, Grant's looks different, so that's another reason I would double check. Because I just see papers that look different. So one of you must be not quite right. Now that looks weird. You sure you followed those directions correctly? Maddie, how are we doing? Just because I can't see. Lift your hand for a second.
What?
The triangle on the top looks a little weird. Same with those of you guys. So wait, if I scroll back up so we can double check the rectangle? Because that means something goofed, right? The first rectangle they had us draw goes up to coordinates, so 5, 0, 9, 0. So the x's are at 5 and 9. So let's double check that we got our rectangle in the right place. So 5 and 9, and then goes up to 8. So from 10, I can count down 2 if I want. And that's in line with triangle B. 8 is in line with triangle B. If it looks weird, it's probably wrong. Sorry. Love you guys, but I'll tell you when you're wrong. If it looks weird, you're probably wrong.
Or at least you'll know.
Looks lopsided. I wonder if there's more directions. So you did the one on the, you did this for triangle C, right? There's another direction for triangle C down here. Did you see that? The original. Hey, so Connor just pointed out a really good point. This step down here starts at the original triangle C, not the one you already moved, because that's now not triangle C anymore. If anything, we call it C prime. So this step down here is telling you, take the original triangle C and do that stuff with it. Wait. Go back to your desk. Just for a second, because I bet you got this. You don't need my help. You just need a moment.
Why would you do that? No, he messed up.
Why would I do what?
How'd you do it?
I said what my messed up graph looks like because I drew it in marker twice.
You did it in marker? You bold man. Bold and silly. Bold and silly. That was a silly choice. Alright, I want to make sure my circle, 7, 6.
I'm all
I'll scroll down in just a second for those of you that are requesting that. If it says translate shape whatever, you're starting at the original.
okay.
So are we all good with the original rectangle, the first circle movement, and the first triangle movement? All right, there are the rest of your directions.
Wait, so, okay, I think mine's completely wrong.
I'm literally not trying to move forward at all, and you're saying, wait. No. You and Patrick can look at each other's and discuss with each other.
Yeah, I don't think that's a very good idea.
What?
In fact, you want to look
Come here.
What? Do you want to give him some advice on what might be wrong? I think you forgot a step on that triangle. It's broken apart on its way back into the atmosphere.
I don't know how this happened. I think I know where it's
So
supposed to be.
this, and then it told you to just slide it to the
Oh my
right.
god, so this is supposed to be at the bottom.
So I believe when you turn triangle C, clockwise record, and then add 15 to each, just X. I
Oh
think you
my
did X
god,
and Y.
I
Yeah.
did X and Y. Okay, so I know it's
Dang, Gus.
supposed to be.
Way to call them out, guys. Whoa, be nice. They're trying to check their work. Now. Hey, so as people finish, I want to explain to you what we're going to do with this next sheet. So when I give you this sheet, it's going to have these 6 shapes on it. You can do whatever you want with these 6 shapes, or you can tell your person to make a new shape. What we're going to do then is the people who get done early can make challenges and describe what they want to do. And then we're able to fold our paper in half, because you want to do it while you describe it, right? So while you're writing, hey, scooch so people can see. While you're writing your descriptions, you're doing it up here. But then when you go to share it with somebody or challenge somebody, you're going to fold it in half so they can't see what you drew and they can just see your directions. Okay, does that make half sense at least?
You have to make your own new shapes then?
You don't have to make your new shapes if you just want to use these.
You have to do this.
I know, but our drawing's going to be on that one too.
Talk about it in a minute. Take that.
Wait, so we take this.
Okay.
So we take this. We
So
write
exactly
our
what, like what they had done with saying, take this shape and do this.
What do we do? There's these shapes here. We do
So you do it there, and then somebody else will do it on their paper, but like separate from you, right? So like either theirs will be blank, or we'll give them a new paper. As long as you show me, whoa.
You would have to ask if Anna got it right.
Well, yes. I've caught Anna a couple times not being perfect.
What?
What?
Max, let me see it.
Yeah.
That goes there.
Don't know why, but I'm pretty sure it does.
Yeah.
Wait, but Mr.
Oh, wait,
Hudson,
no.
why is there a random circle right there?
Don't. We'll talk about it in a second.
Why is there a circle right there?
Crap, where did it go?
Where are the last directions? I can't read them very well. Yeah, I can't read the last directions either.
Copyright infringement is totally happening right now. You're missing one thing. Oh, you gotta write descriptions about your
Okay, you're respectable. You have a 3-year-old sister. You have a choice.
Yes. Anyone who doesn't have this paper, you gotta come around just to get this in your hands. There you go.
Yeah, she plays something. I remember she's watched the show at least 5 times.
In Washington, D.C., we went on a riverboat cruise on our trip. That, like, you know, we take like a spring trip normally, at least pre-COVID times. There was a karaoke contest. And, of course, Phoenix kids being Phoenix kids, the song they chose, or it wasn't karaoke, I forget what it was. They chose to sing the Little Einstein's theme. And everyone else on the boat was older than us, like they were in high school or college. Or it was real funny. Your wings are incorrect. Is that like the check those directions? We also I have 2 extras, so I'm guessing we just have people missing.
I don't know. I can get one.
Okay, coming back. Alright, why did I play Little Einstein? Did you get one of these things that's sitting right here an inch from your hand?
Yeah, I did.
If it was a snake, it would have bit you and you'd probably die.
That doesn't sound good.
Well, I have a lot of white papers.
Yes.
Because rocket ship.
Because rocket ship? So, Jordan says cuz rocket ship. Sounds like it's spelled C-O-S, cuz. Or C-U-Z. So, rocket ship. But then, what would this be? It's the moon! Next, we're gonna blast off and go to the moon.
Why is it so small?
Because it's far away. It looks small. It's perspective.
That's a bad reason, and you know it, Mr. Hudson.
Well, I mean, everything looks small and far away. You don't want to tessellate? Okay.
No, I haven't seen it. I mean, the kid on the poster wants to tessellate.
Yeah. Nice.
It sounds not good.
Where?
Well, because that's a why do I need math poster, and the kid says, because I want to tessellate. Tessellations are super fun. I showed you guys the math art stuff, right? I'm going to try to make copies of that and put it on the bulletin board out in the hallway.
I hate that when I study algebra because it has stuff like, I'm like super into quadratic equations, and it's like, that's not the answer.
I mean, I'm super into quadratic equations.
And look at where you are, Mr. Hudson.
Yeah, I made a trebuchet when I was in college.
A what?
A trebuchet. So come at me, man. If I do my quadratic equation right, I'll hit you with it as long as you're standing in just the right spot. Trebuchets are very inefficient weapons. If you don't know what it is, look it up. It's like a catapult, but they used a lot of engineering. They were super cool. I might just show you one because I just talked about it.
It is a threat.
And then
How do you try the persons?
Make sure to like and subscribe. Make sure to like and subscribe because this content is in desperate need of money. Otherwise,
Yeah.
I'm in desperate need of what now?
Money.
I mean, I'm not really in desperate need.
Money. Well, you sort of do. Yes, you did. Money.
This is a trebuchet.
You built that.
No, I didn't build this one, but this is a trebuchet. We built a very small version for my friend who was going to CCAD for something, I forget, but one of his project options for his class was build a trebuchet. So how Trebuchet works is the arm at the back of it is very short. And this is actually, a student of ours made a trebuchet for a Discovery Day project. Because you can make them any size you want. But the back part of the arm is very short. When you release the weight needs to be extremely heavy. Because look, this doesn't fall very far, but then it swings around. So what you're actually making is a circle of energy. So the weight swings around. And because because the object is on a tether, it whips it. You know, like when you play Crack the Whip?
Yeah.
So it has to release the tether at just the right spot. So there's a hook on the end of it.
How far does it go?
Watch.
It's like the scene from Lord of the Rings.
Yeah, they use trebuchet.
Holy crap!
Whoa.
Yeah.
I did that.
And if you've done your math right, it's extremely accurate. Yeah, look at where I am today. I'm in a pretty good place.
You did not make one of those.
Yes, I did. And then it tipped over on my buddy's car.
Oh.
Yes,
Whoa,
it
how
tipped
big
over
was
because we
it?
didn't have the counterweights correct and the base wasn't heavy enough and we launched it and it launched and then it tipped over and it hit my buddy's car.
Dang, I need to walk.
Yeah, I don't know why he parked there either. I blame Ian Sanderson for that choice. Ian, I might email you this video. I'm still talking about you in class today.
Hello, Ian, whoever you are.
An amazing musician, friend of mine from college.
You're an amazing musician, a good friend, my math teacher from college.
I gotta see if I still have his email.
He has to see if you.
If you ever his last name, then you have his email.
Did I show you guys the Desmos art contest stuff?
Yep.
Yes. What? No.
So at this point, because you're starting to learn more about how these things work,
We can make art.
you'll understand a lot of, like, if you go look at the Desmos art stuff and you look at what the graphs are, it'll make sense that when they say triangle, blah, 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 you're like, oh, those are the vertices,
I did it.
right? So if you tell it make a triangle and then you tell it the vertices, boom, you get a triangle.
Whoa, wait, really?
There are ways to learn in Desmos. If I had an infinite amount of time with you guys, we would spend a ton of time just playing in Desmos, but I don't have an infinite amount of time, so it's something you got to do on your own.
Can we make a new?
So if this is something I'll say that, like, I'll support if you end up having to do this with your advisor teacher, if your Discovery Day falls through for some reason, you could legit do a Desmos Discovery Day. But you gotta have something substantial to show of how it took you a day to learn what you learned. So that is an option.
It reminds me of coding.
It is a lot like coding.
With numbers. Well, maybe like with graphs, maybe.
Yeah.
I'm gonna
Trying to
make.
think of what's different from that than coding.
And because we're just kind of hanging out working on this, I sort of want to start this series with you guys.
Okay, go.
No, that's normally reserved for Fridays. So as we get towards winter break, I'm going to try to, like, piece this out so we can end up watching / listening to most of this before the end of the quarter. So I should probably stop recording.
In the middle.